A solution is a homogeneous mixture composed of solute dissolved in solvent. If the solvent is water, then our solution is called an aqueous solution. The solute can be solid, like dissolving salt in water. The solute can be liquid, like dissolving acetic acid in water, which is also known as vinegar. And the solute could be gas, like when dissolving carbon dioxide in water, which is soda water. Concentration measures the strength of a solution and is expressed in terms of molarity. Molarity is abbreviated with a capital M and is defined as the moles of solute divided by the liters of solution. Let's take a closer look at concentration and molarity. In our first picture, we can see that 1 mole is being dissolved in 2 liters. To calculate the molarity, we use the definition and divide 1 mole by 2 liters. Therefore, the concentration of solution A is 0.5 molar. Solution B is made by dissolving 2 moles in 2 liters. To find the concentration of this solution, we use the definition of molarity again and divide 2 moles by 2 liters. Therefore, solution B has a concentration of 1 molar. So, solution B is stronger than solution A because the concentration of B is 1 molar, while the concentration of A is 0.5 molar. Notice that if I were to add more moles to my solution, the concentration would increase. However, if I were to add more solution, the concentration would decrease. Let's take a look at some different kinds of molarity calculations. Number 1. What is the molarity of a solution made by dissolving 63.1 grams of potassium chloride in 125 milliliters of water? Remember that molarity, capital M, is equal to moles of solute over the liters of solution. We are dissolving potassium chloride in water, so potassium chloride is the solute, and therefore we're going to need moles. So let's convert our 63.1 grams of potassium chloride into moles by using the molar mass from the periodic table. The mass of potassium is 39.10 grams per mole. The mass of chlorine is 35.45 grams per mole. Adding them together, we get the mass of potassium chloride, 74.55 grams per mole. Let's put that in to our calculation. Keeping the grams on the bottom and moles on the top. We get 0.846 moles of potassium chloride. So we have one part of our molarity definition. Now we need to get the liters. So we are told that we have 125 milliliters of water, and our molarity definition is in units of liters. So let's convert, because there are 1,000 milliliters in 1 liter, and so we get 0.125 liters. Now that we have the second part of our molarity definition, all we have left to do is divide. So the molarity of this solution is equal to 0.846 moles divided by 0.125 liters. And we get 6.77 molar potassium chloride solution. Number 2, how many grams of nickel nitrate are needed to make 2.25 liters of a 6.85 times 10 to the minus 3 molar aqueous solution of nickel nitrate? Before we solve the problem, let's draw a picture so that we understand what this problem is asking us. If we have a beaker with 2.25 liters of water, we want to know how many grams of nickel nitrate must we add to make a solution that has the molarity 6.85 times 10 to the minus 3. And remember that molarity is defined as the moles of solute, in this case nickel nitrate, divided by the liters. Since we want to know how many grams of nickel nitrate we need to add to the beaker, we will first need to calculate the number of moles. We can then convert our moles into grams using the periodic table. We already know the molarity and have written it using its definition. Since the liters are on the bottom here, we can multiply by the liters of our solution, which is 2.25 liters, and cancel our liters out in order to tell us how many moles of nickel nitrate we must add to the beaker. Now we can convert our moles into grams using the molecular weight of nickel nitrate, which we can calculate from the periodic table. Nickel has a molar mass of 58.69 grams per mole. Nitrogen has a molar mass of 14 grams per mole, and we have 2 nitrogen atoms. And oxygen has a molar mass of 16 grams per mole, and we have 6 oxygen atoms. Adding the masses together, we end up with 182.69 grams per mole. So putting that into our calculation, and canceling out units, we can see that we've ended up with grams of nickel nitrate, which is exactly what the problem is asking us. So doing the math tells us that we would need 2.92 grams of nickel nitrate added to 2.25 liters of water to make a solution with the molarity 6.85 times 10 to the minus 3.